Hello students, how are you? Are fine? I hope all of you fine only. So students, today I am present here again for class 12th chemistry, unit 6 English medium students. So students, unit 6, the chapter number unit 6, general principles and processes of isolation of elements, that is about metallurgy. So students, as we have discussed earlier, whatever metals are obtained by extraction from the concentrated ore of the metal, such metals which are extracted and separated, okay, such metals are also not completely pure. So we cannot say that purity of such metal is completely it is 100% pure only. So still there are some impurities present in the metals which are extracted from the concentrated ore. So if we talk about like method for extraction, like roasting method or calcination method, so we know very well that after roasting or calcination method, using this method, the metals are converted into its oxide form, and when we do the reduction of the oxide of such metals, after that whatever form of the metal is obtained, okay, they are known as crude metal. So students, you know that such crude metal, they are also not completely pure. Still the impurities are present in such crude metal also. So what to do then to get the pure metal? So students, you know that for the purification of such type of crude metal which are obtained by the extraction of concentrated ore, such crude metal are purified or refined by using some techniques of refining, by using some processes, by using some techniques of refining. And actually what happens, such crude metals, they consist they are still contaminated by some proportion of impurities, okay. So still such metals are needed to be purified. So which processes are used, whatever the principles are used, on which type of principle the different processes has been developed for the purification, for the refining of such crude metal, okay, that is all actually based on the differences between the physical and chemical properties of the impurities as well as the pure metal present in the crude metal. So students, based on this principle, we are going to see the different processes. Now students, for that we are going to study about the new topic in this chapter, that is about refining of the crude metals, which is obtained, the crude metal has been obtained from the extraction of the concentrated ore, extraction of metal from concentrated ore by undergoing roasting, calcination, as well as reduction of oxide of metals. So for the refining of these crude metals, okay, these are some refining processes which has been listed here, okay. We can see these refining processes which has been listed, and these processes has been developed on the differences in the physical properties of the impurities as well as the pure metal. So now students, see which are the processes here mentioned. These processes are nothing else but distillation, liquefaction, electrolytic refining, zone refining, vapor phase refining, and chromatography. So students, one by one we are going to discuss about all these processes in detail. So before that, you copy this name of these processes which are listed here. So students, now see, now students, we are going to see about the refining techniques and uses of the metals, okay. Now you can see here how this ore is converted into its crude metal, how this ore is converted into its crude metal, that is converted into its crude metal by extraction, and how this crude metal is converted into pure metal, that we are going to see, students. And for that we have to do purification or refining techniques. So here students, we are going to see about the purification and refining techniques. So for that the metal refining methods. The metal refining methods has been mentioned here. Some metal refining methods you see, students. Which are the metal refining methods? See, there are 6 methods which are shown here. First one is distillation. Second one is liquefaction. Third one is electrolysis. Fourth one is zone refining. Fifth one is vapor phase refining. And sixth one is chromatography. So students, all these metal refining methods we are going to study in detail about all these methods. So one by one we are going to discuss about this. So students, now see here, first this is the apparatus setup for the distillation. In this way we have to set up the apparatus. This is retort, this is condenser, this is receiver. So students, see distillation method. In this distillation method, this distillation method is used actually for the low boiling metal. That means the metal which get vaporized very fast. So for that, examples are zinc, cadmium, mercury. So such type of low boiling metals are purified by this distillation method. So here actually what is happening, we have to take the impure metal in a glass retort. So this is what, this is actually retort, not glass retort, this is a retort, and this impure metal is heated. So they in that the pure metal vaporizes, the pure metal which is having low boiling point, such pure metal get vaporizes, and they will pass from the condenser and they will condense there, and they will collected in a different container called receiver. So students, you can see here what is happening here. Here pure metal is collected here in the receiver because they have low boiling point, and the non-volatile impurities, they remain in the retort only because their boiling point is high. Now see second method, students. So this is the setup of the second method, that is liquefaction method. In this liquefaction method, on a sloping surface, okay, the high melting metals, the low melting metals are used for separation by this method. So this is used when the impurity is less fusible than metal itself. So this method is used for the separation of the low melting metals. So students, you know that powder form of the crude metal is placed on the sloping surface, and you know that below the sloping surface, a powder form of metal like tin or lead, okay, so that is placed on the sloping surface, and below the sloping surface you can see there is a furnace. So here heating takes place, and this is the sloping surface. So what will happen when the heating takes place? The low melting metal, that will melt fast compared to the impurities. So impurities will left behind here only, and the metal which get melt here, like tin or lead having low melting point, they will melt here, and by melting they will flow from this sloping surface, and they will collected in the, see this molten metal flow, and they will collected in a separate container. And here infusable impurity, that is the impurity which is having high melting point, that will remain here only because it will not melt in less temperature. Now students, we are going to see the third technique, that is about the electrolysis. So students, about electrolysis you have already studied in third chapter in electrochemistry. Students, actually what happened in this technique, the anode is made up of the impure metal, and about cathode, so cathode is made up of the pure metal. And so here you note that both metal are same only, and electrolyte is used, that is actually the aqueous solution containing a soluble salt of the same metal. So students, what happened in this way, the setup is made, anode, cathode are dipped in the electrolyte, and when the circuit is completed, electric current pass through the anode. What will happen here? Anode will undergo oxidation by losing the electron, and cation will go in the solution. the cation from the solution will gain electron and convert into metallic atom, and they will deposit on the cathode. So cathode will undergo reduction. Anode oxidation, cathode reduction. So this is the type of redox reaction. And students, you can see here below anode there will be the collection of the inert metal, chemical inert metal, like they are known as anode mud. Students, let me tell you that in this anode mud there are the chemical inert metal like gold, silver, antimony, tellurium. Such type of metals are collected here. Now for that, let us take one example. Electrolytic refining of copper we have taken here. Electrolytic refining of copper. So here, students, you know that cathode is made up of impure copper. Anode is made up of impure copper. Anode is made up of impure copper, and cathode is made up of pure copper. So cathode is made up of pure copper. And the electrolyte solution is taken as acidified solution of copper sulfate. So in this acidified solution of copper sulfate, students, blue color solution is there. So in this acidified copper sulfate solution, which is acting as the electrolyte, this anode and cathode are dipped and the circuit is completed in this way. This is the battery. When the current is passing from the battery to the anode will lose electron and positive ion will go into the solution. Cu2 plus ion are going in the solution. They will gain the electron from the solution and convert into copper metallic atom and deposit on the cathode. So on cathode what happen? Reduction will take place, because gaining of electron is happening here on cathode, losing electron happening on anode. Anode oxidation, cathode reduction. And students, see what else will happen here. Here the impurities, different type of impurities which are present here in this anode, like we can say that sulfate impurities. Okay, the sulfate impurities, these sulfate impurities like ferrous sulfate, nickel sulfate, zinc sulfate, these are the impurities. Okay, so these impurities will go into the solution. And if we talk about the anode mud, what we have seen here below the anode. Okay, so in the anode there are the chemically inert metals like precious metal like gold, silver, antimony, tellurium, platinum. In such type of chemically inert and precious metals, they are collected below the anode, and they are known as anode mud. They are known as anode mud. So students, you know that using this technique, okay, recovery of the cost is also happening by using this technique, because you are getting here precious metal. So cost is get recovered here. So as you are getting precious metal in the anode mud. So other metals like silver, zinc, lead are also purified by using this electrolytic refining method. Silver, zinc, lead, all these are purified by using this electrolytic refining method. So students, this is very best method. It gives about nearly 99.99% pure metal. So by using this you are getting 99.99% pure metal. Now students, we are going to see the fourth method, that is called zone refining method. Now see, in this zone refining method what is happening. Let us first see the principle of zone refining method. So you know that principle is impurities are more soluble when the metal is in its molten state compared to when the metal is in its solid state. So students, you know that impurities are more soluble in the molten state of metal compared to in the solid state of metal. So this is the principle, and using this principle, this zone refining method is used for obtaining metal with very high purity. They are used for purification of the metals like germanium, silicon and all that. Now students, this is the setup for zone refining. You can see here cylindrical container is there. Inside that inert atmosphere is kept, and inside that impure metal is also kept here in the cylindrical container. And you can see students, this is what the circular heating roller. Okay, this is actually the mobile heater, because this can move from left to right. This can move throughout the cylindrical container. And this is the impure metal. Here inert atmosphere is also there. Now students, what will happen? Wherever this circular heater will move, what will happen? See, you can see here, there what happened, molten zone produced. So wherever is the position of this heater, okay, circular heater, there the metallic rod will will come in its molten state. So you know that in this molten state the impurities will get more soluble, so impurities will move along this molten state only, and wherever the heater is leaving the position, there the metal cools down and again get crystallizes. So this process is, student, repeated again and again, and by repeating the same procedure again and again, by moving the coil, by moving the heater in the same direction from left to right, what will happen? The impurities are moving along with the molten state from left to right in one direction, impurities keep shifting along with the molten zone from left to right direction, and what happen in the opposite direction, the metal is getting cool and crystallized again. So you are getting here pure crystallized metal. So students, by using this technique, afterwards what happen, whatever the end of the metallic rod having contaminated with the high impurity, such end is cut off and removed away. So this end, you can see, this is cut off and removed away. So along with this removal part, the impurity is also getting removed away. Now by using this zone refining techniques, the elements like germanium, silicon, gallium, this type of semi-metallic elements are purified with very high purity. You know that silicon, which is used in the semiconductors, silicon and germanium, which are used for making semiconductors, okay, they are purified by this technique. Now students, we are going to see the fifth method, that is about vapor phase refining method. So for that, this is the setup, students. You can see here, actually this is in this method, the impure metal that is actually reacted with the reducing agent like carbon monoxide. So here metal carbonate is formed. So first step is what, to convert the impure metal into its volatile form, and second step is to decompose the volatile form to recover the pure metal again. So this is the concept, this is the principle in which the vapor phase refining is working. So first step is converting the impure metal into its volatile form and then decomposing the volatile compound to recover the pure metal back. So here students, what happened, here let us take one example and explaining you here. So you can see here cells containing crude nickel. So crude nickel, that is impure nickel, is purified in this way. So you know that impure nickel is reacting with the carbon monoxide gas. So when they react with the carbon monoxide gas, what is happening? They form the volatile compound. And what is that volatile compound? That is nothing else but complex, nickel tetracarbonyl complex. Nickel tetracarbonyl complex is formed, and it has property of getting volatile as well as it has property of getting decomposed. So this is now passed in the another decomposition tower, you can see. So when they pass from decomposition tower, they leave back, they separate into nickel pellets, pure nickel pellets. You can see pure nickel pellets is separated and carbon monoxide is again separated. This carbon monoxide, you can see that is coming back and it is again getting reacted with the impure nickel. So students, you can see this, in this way the cyclic processes goes on, where carbon monoxide is used again and again to convert the impure nickel into pure nickel. So after passing this, okay, so now students, you know that this process has been developed by scientist named Mond, and that's why this process is also known as Mond process for refining nickel. In the same way, another vapor phase method is used named as Van Arkel de Boer method. This is also given name by name of scientist only, and you can see this is the setup, students, and these are used for purification of the metals like titanium and zirconium. So in this method, what is happening actually? The impure titanium or zirconium, okay, that is actually heated in a vacuum container, in a vacuum system along with iodine. So you can see here iodine container is there. Impure titanium and zirconium are heated here along with iodine in a vacuum. You can see here therefore supporting molybdenum is there. So when they are heated, what is formed here? titanium or zirconium tetraiodide is formed. So this metal iodide actually they easily convert into vapor phase. Okay, so they get decomposed. So now this again we can recover the metals. So these are actually titanium or zirconium tetraiodide. These are heated on the tungsten electrode, tungsten wire, okay, at 1800 Kelvin temperature. So when zirconium tetraiodide or titanium tetraiodide are heated at 1800 Kelvin temperature on tungsten wire or tungsten electrode, then what happens? Pure titanium or zirconium are obtained on tungsten electrode surface. They deposit there. So in this way they are separated by vapor phase refining method. Now students, we are going to see sixth method, that is chromatography. Now you know that in this chromatography method, what is the main principle here? So chromatography method, you can see here, metals and impurities are separated by their differences in their relative adsorption with an adsorbing medium. So students, you have already studied about the adsorption in chapter number 5, surface chemistry. So about adsorption phenomena, okay, let me tell you that this adsorption phenomena, they occur on the surface only. So let me explain you that this is the column in which stationary phase has been taken, and this is the mixture to be separated. Now the mixture which has to be separated, that should be poured on the stationary phase. So you can see here the mixture has been poured on the stationary phase. But now this mixture is not separated just now. Now when we add this mobile phase, when this mobile phase is added here, due to the mobility of this mobile phase, what will happen? Different components in the mixture, they will start flowing with different rate flow. Now see, immediately they start flowing. So different components having different speed of their rate of flow, okay, so they will flow with different speed. And what will happen? Different components are separated in different container. You can see here, first component is separated, second component is separated here, and then third component. Student, let me tell you, the component which is having more speed, which have more rate of flow, okay, they will make lower layer here and they will separate first, and the one which have low speed, they will separate last. So this is separating last. So you can see here, three components are separated in three different containers. So this is also one of the best technique for separation. Now let me explain you this by taking some example. So this is actually the mobile phase, students, and this is the mixture to be separated, and this is stationary phase. So first the mixture to be separated is added on the stationary phase. The stationary phase has been kept in a vertical column here. It is just like the apparatus is just like a butyrate only, and here the beaker is placed here at the bottom. So students, let me tell you, when instead of that when paper is used, chromatography taken paper, then paper, it is called paper chromatography. When column is used, then it is called column chromatography. When gas is used, then it is called gas chromatography. So chromatography are three types. Now what is column chromatography that we are studying? So column chromatography is used for the purification of elements that are available in minute quantities. So students, let me tell you, the elements which are present in very minute quantities, okay, for the purification of such elements, this column chromatography is used. And the chemical properties of the impurities are not much different than that of the element to be purified. So whenever the differences between the chemical properties of element and impurities is very less, when the difference is very less, at that time this column chromatography technique is used. Now students, let us take one example here. See, this is the column and this is the stationary phase. What we have taken as stationary phase, students, we have taken alumina or silica gel. So this alumina or silica gel, they act as a stationary phase. These are the best example of stationary phase. Now see students, here this is the mixture to be separated. That means the components of this mixture should be separated here. So this mixture we are adding here on the top of this stationary phase in this column. Now these components are just not separating until and unless mobile phase is added. Now this is the mobile phase. It is also called as eluent. So now when this is added, each component of this mixture will immediately separated with their different mobility, different rate of flow. Now see this yellow color, okay, it has more rate of flow, so it's separated first, making lower layer. After that, second number, blue color component you can see here, it is separated in separate container. And this red color, which is the having less rate of flow, less speed of mobility, okay, that is separated at the last in the third container. So in this way, all the components of the mixture are separated in separate container. So this is also used as best technique. This is best technique for the separation of the impurities from the metal and to make the metal in its pure form. So students, these are the methods to be used for the purification of the metals. Thank you.